In 11.2, we are now going to complete the square in order to find the roots, the zeros, the solutions, and sometimes it's called intercepts. These four words, roots, zeros, solutions, and even intercepts, are interchangeable. Some test questions might ask you for roots. Some test questions might ask you to find zeros. Some test questions might ask you to find solutions. Some test questions might ask you to find x-intercepts. They all mean the same thing. And the process that you learned how to do in 11.0 and 11.1 is the same process we're going to do here with a few minor changes. Just like in 10.5, when you square root something, when I think about x squared equaling, let's say, 16, there's two possible answers for that. 4 times 4 is 16, and negative 4 times negative 4 is 16. There are two possible answers, so whenever you square root something squared, if I square root both sides, don't forget that plus or minus sign because there are two possible answers. It's also equivalent to an absolute value. Lastly, there are going to be three questions on this worksheet where you're going to square root and you're square rooting a negative number. If you square root a negative number, that is not a real number. For now, we're going to write that it's no solution, or there are no zeros or no x-intercepts. When we get to 11.3a, we will be able to start solving problems like that. We just can't do it yet because I have to do a whole nother section to explain what the opposite of a real number is. It has its own section. Okay? So that's to come. Let's say that we're just foreshadowing that just a little bit. So these 7 steps are the same up through number 4. They're the same as what we did in 11.1. The biggest difference is that we have a step 5 where we square root both sides, including that plus or minus. Get the x by itself and combine terms if possible. Sometimes we will, sometimes we won't. When you are first starting these problems, you should probably have these 7 steps next to your worksheet so that you know what you're doing as you do them. Let's do some examples. Step 1 says, move C to the other side. So this is number 1 on your worksheet. You can do this on your worksheet. I would move the 12 to the other side. And then I would leave an underscore there. That's step 2. An underscore is a fancy way to say draw a line and leave a blank spot where something's going to be. You're going to need to put something in the underscore. I think that's step 3. What does step 3 say? Somebody read it for me because I don't know. So we need to add b divided by 2, or half of b squared. If I need to add half of b squared, it's based off of this number. You have an x squared. That's a perfect square. A to the x is, remember how when we were doing the completing the square, we put 4 on one side and we put 4 on the other? Half of it was 4, and then you squared that. So I'm going to put in parentheses plus 4 squared in that underscore. I don't have to simplify it here because this is going to factor perfectly. But whatever I put in this underscore, I need to put in this underscore. And I should probably simplify it. If this is plus 4 squared, I'm really adding 16. I do need to simplify that over there. We've added this blue amount on both sides. This side will factor perfectly. Every single time we complete the square, it's these 3 things, and they factor into a perfect binomial square. Or this trinomial square is a perfect binomial square. The x goes here. What goes there? Plus 4. Whatever you added, half of b is going to go there every single time. Half of b goes there. Equals. Now on this side you get 28. which brings us to step number 5. We've done step 3, we've done step 4. Step 5 says this is where we square root both sides. And don't forget the plus or minus sign. So to get rid of this square, we square root. I'll do this step in blue. When you square root something squared, it doesn't matter that it's in parentheses. You still put that plus or minus sign in front of that square root of 28. These two things will cancel each other out, and you're left with an x plus 4. On this side, that plus or minus sign, the 28 breaks down into 2 times 2 times 7 times, or 2 times 2 times 7. Doesn't that simplify? If you have one of the fancy calculators that I've recommended to you, you can easily type in root 28 and it will stay in radical form. Not all calculators do this, but if you have a calculator that does it, why not use it? I have these in my classroom. You're welcome to use those in my classroom because it will reduce it for you and keep it in radical form. Or you do it by hand. How do I do it by hand? You look for two factors that are the same and it breaks out. The plus or minus sign is 2 root 7. Now this has a root 7 with it, which might make you think that something's funny here, but all we have left to do is, I think step 6 says, get the x by itself. What's next to the x I have to get rid of? Plus 4. What's the opposite of plus 4? Minus 4 and minus 4. And I want you to put the minus 4 in front of the plus or minus 2 root 7. Get used to doing it that way. X equals negative 4 plus or minus 2 root 7. Your step 7 says combine these if you can. But let me make a reminder to you. Root 7s can only add with other root 7s. Root 6s can only add with other root 6s. Square roots can only add or subtract with other things that are exactly the same. These aren't the same. You can't put them together. This is your final answer. It's an ugly answer, but it is your answer. Your answer is negative 4 plus 2 root 7 and negative 4 minus 2 root 7. It's not hard. It just doesn't come out nice and pretty. So what happens if the C value is already moved? I chose number 3 for you on your worksheet as well. If the C value is already moved, you can go directly into step 2. Step 2 is put those underscores there so you know that you got to put something inside there to complete that square. Here's your B. We're going to add half of B squared. What I like to do is put plus, and then even if it's a negative, I usually will put that negative inside parentheses because then when I go to factor it, I don't forget to put the negative. But over here, negative 9 times negative 9, I put the actual, like, what is it? I simplify it over there. The only reason I don't do the simplifying here is because it's going to factor perfectly every single time into whatever that B was. Half of B goes right there, including the same sign as the middle. It goes from that into a perfect trinomial squared. Equals 81 minus 57. I don't know what that is. I'm going to use my calculator. The opposite of a square is square rooting. I'm going to square root the left side. I'm going to square root the right side. But because I am square rooting something squared, I put a plus or a minus sign there in front of that radical. These two things cancel each other out. You're left with an x minus 9. Now, some of you know how to break this root 24 apart by hand. If you do not know, you're looking for pairs. The 2 pops out. The 6, there's a 2 and a 3, but there's no pair, so you might as well just leave it as a 6. Or you just go to your calculator and type in root 24. Let the calculator put it in lowest terms for you. You only have one more step to do, which is get the x by itself. Add 9. And we're going to put that 9 in front of the plus or minus sign every time. You cannot add the 9 and the 2. They are not like terms. You can only put root 6's together with other root 6's. Simple? So what happens if you have a number and there's another number there? The C value's here and there's another number. You're still going to move this by adding 46 to this side. You can just kind of do that and leave the underscore. That's why I chose 6. 46 minus 2 is 44. Put my underscores there. I'd look at this negative 20 and then I add half of it squared to both sides. Half of it, so for me, I go, oh, half of negative 20 is negative 10, and I have to square that to make that perfect trinomial square. I put the negative inside there, even though negative 10 times negative 10 is a positive 100 on this side. This left side factors perfectly. And every time you take the square root of this, you square root of that is just negative 10. It's got to match that sign. 144. We've completed the square. All we have to do now is square root both sides. Don't forget the plus or minus sign. In this case, the square root of 144 comes out to a nice whole number. Don't forget the x minus 10 is still x minus 10. We still add 10. We still add 10, and I want you to put it right in front of that plus or minus 12. I want you to know what that means, so I'm going to write it over here. 10 plus or minus 12 means 10 plus 12 and 10 minus 12. These are going to be our two solutions. You guys know how to do 10 plus 12. If you can simplify it, simplify it. 10 plus 12 is 22. That's one of your answers. 10 minus 12 is negative 2. Our two solutions. Sometimes they simplify to negative 2 and 22. If it comes out to a nice whole number, you will be able to find the two solutions. If it stays in radical form, you will not be able to put them together, just so you know. And then sometimes you're going to square root a negative, and then it's no solution. The last thing that you have to be able to do is to graph. We're going to still take this and we're going to put everything together with what we did in 11.1. In 11.1, we learned how to take this and put it into vertex form by completing the square. So we're going to do that here. We're going to add the 15. This becomes y plus 15, put an underscore, x squared plus 2x, put an underscore. Something's going to go in there. We got to complete the square on this. This time, if my b value is a 2, half of b squared is I'm adding 1 squared to this side. I'm going to add 1 squared to that side, which is 1. And this factors perfectly. These two things you can simplify. The last thing you do is you subtract the 16 to the other side, and that's what your answer is in vertex form. It's y equals parenthesis x plus 1 squared minus 16. So where's my vertex? My vertex is at opposite, same, negative 1, negative 16. Paramo. I'm teaching. Yes. Yes. Okay, bye. So, we got the vertex. The y-intercept, so the next thing that is the easiest thing to find. How do I find the y-intercept? I plug in a 0 in for x. If I plug a 0 in for x, it's easiest to do that right here at the beginning. If I had a 0 squared plus 2 times 0, let's just put a 0, minus 15, I know what y has to equal when x is 0. It's that c value. And all this should start matching up with graphing what we did last unit. If we have negative 1, negative 16 down here, let's call this negative 1 and this is negative 16. The parabola opens upward. Then the y-intercept makes sense that it's like at negative 15 where it crosses the y-axis, like that should make sense. So where do we find the x-intercepts? Remember how we just completed the square? We're going to do the same thing. If the y value is 0, we can find what the x's are. So think about if y was 0 here. If I plugged in 0, if I plugged in 0 right here, I'm going to erase that. I'm going to erase that. If I plugged in 0 right there, you would have x plus 1 squared equals 16. You could square root this side and square root this side, and you get plus or minus 4. You could subtract the 1. Put that in front of the plus or minus. And you could find the two places where it's going to cross. Negative 1 plus 4, negative 1 minus 4. Negative 1 minus 4 is negative 5, 0, and 3, 0. Negative 5 and 3 are where it's going to cross the x-axis, which hopefully matches up with what we do when we graph these kinds of problems. I'm going to stop your notes right there.